A closed coiled helical spring is made of a wire of diameter 20 mm. The mean radius of the coil is 80 mm. Find the number of turns required and the maximum axial load if the shear stress is not to exceed 100 MPa and maximum elongation is limited to 30 mm. Take G is equal to 80 MPa. I think we have to make one correction here. See, G means modulus of rigidity or shear modulus. It must be 80 GPa, not MPa. Okay, you given wrong unit. G must be 80 GPa. Okay, na, not MPa. So MPa ni ichadu, actually the wrong measurement adi. GPa untundi actually. Okay. So G is equal to 80 GPa. GPa means gigapascal. Okay. So anyhow, here is given closed coiled helical spring. Closed. So closed end. Closed coiled helical spring. Helical spring. So based on given data, here we have to apply torsion in springs concept. So anyhow, first of all, let us list out given data. First question lo emi ichchado mundu data anedi mundu note chedam. So he given wire diameter. So spring wire diameter. He given wire diameter. Wire diameter generally denoted by small d. Small d is equal to 20 mm. Next, mean radius of the coil. Mean radius of the coil. Mean radius of the coil. So denoted by capital R is equal to 80 mm. Next, we also given maximum shear stress. If the shear stress is not to exceed 100 MPa means he given maximum shear stress. So maximum shear stress induced in the wire. Maximum shear stress. So maximum shear stress induced in the wire. Tau maximum, let us say tau max, is equal to 100 MPa. 100 MPa. And he given maximum elongation. At the same time, he given maximum elongation. Maximum elongation. So maximum elongation. Maximum elongation. So let us say delta max. Maximum along delta maximum is equal to given 30 mm. Take Z is equal to 80 GPa. Given wrong unit, please consider GPa. Otherwise, you will get wrong answer. You won't get a number of turns. So 80 GPa. So let us convert GPa into Newton per mm square. Say. So or MPa. 80 GPa can be written as 80 into 1 GPa is equal to, remember, 1 GPa, 1 gigapascal. 1 gigapascal. 1 GPa is equal to 10 cube MPa, 1000 MPa, megapascals, unit conversion. 1 GPa is equal to 10 cube megapascals. So 80 into 10 cube MPa, megapascal. Again 1 megapascal is equal to how many Newton per mm square? 1 MPa is equal to 1 Newton per mm square. 1 Newton per mm square. Okay. So we need two things here. The first thing is axial load, maximum axial load. So denoted by capital W. Next we need number of turns. So number of turns denoted by small n. This is the given data. Based on this given data, we have to find axial load and number of turns. So you need to find out here. So first let us find axial load. Okay. So first let us find axial load on spring. Axial load on spring, helical spring, closed coil helical spring. So, denoted by capital W. So, given maximum shear stress induced in the wire. We know that in case of design of closed coiled helical spring, when it is subjected to axial load, maximum shear stress induced or developed in the Y, maximum shear stress induced in the Y is given as tau max. Tau max is equal to 16 WR by pi dt. 16 WR by pi dt. So this is the formula for finding maximum shear stress induced in the Y. So here we need W. Here W means what? W ante enti? What is W? W means axial load on spring. Manaku kavalsindi idi W. Okay. Just transpose all the terms. Then W is equal to, I need only W. Transpose pi d cube. Division becomes multiplication. Now tau max into pi d cube. Okay. So 16R. Multiplication becomes division. So the division like divided by 16R. Now substitute all the values. Tau max how much? Maximum shear stress is given 100 into pi into d cube. Diameter of Y 20 mm. So 20 cube by 16 into R how much? 8. Okay. Now W is equal to 100 into pi 20 whole cube. 20 whole cube how much? 8,000. 8,000 whole divided by 80 into 60. 80 into 60. 80 ones, 80 thousands. Sorry, 80 hundreds, 8,000. Okay. Now W 100 into 100. 100 into 100. 10,000. Okay. Or we can write 10 power 4 into pi whole divided by 60. Now W is equal to. So if you calculate this value, you will get W as. So here I got 1963.5 newtons. Okay. Therefore, axial load on spring is 1963.5 newtons. Okay. Na? Next, let us find number of turns. So we find axial load on spring. Now we need number of turns required. So let us find number of turns required. Number of turns required. So denoted by small n. So number of turns required is actually calculated from deflection formula. We know that the maximum deflection of the spring, maximum deflection of the spring, maximum deflection of the spring is given by, very important formula is given by delta is equal to 64 W R cube n by g d power 4. Okay, this is the deflection formula. Delta is equal to 64 W R cube n by g d power 4. Here only unknown is n. What is n? Here n is number of turns required. We need n. So n is equal to, we can rewrite this formula as transpose g d power 4. You will get g d power 4 into delta by 64 W R cube. Transpose 64 W R cube. It goes to the denominator. So 64 W R cube. So we can write N as GD power 4 delta by 64W R3. Now substitute all the values. 6G, what is G? What is the value of G? 80 into 10 cube. D power 4. Here diameter of the wire is 20. So 20 power 4 into delta. Delta is given 30 mm. Whole divided by 64. Deflection, I think we have got 1963.5, I think around, yes, into R cube means 80 whole cube. 80 whole cube. Now N is equal to, let us simplify further, 80 into 10 cube into 20 power 4 means 20 into 20 into 20 multiplied by itself how many times? 4 times. Into 30 whole divided by 64 into 1963.5. I just want to do manual calculations without doing calculator. See, 80 get cancelled. Okay. Now next 0 0 0 0 get cancelled. 2 2s are 4. 2 2s are 4. Okay. 4 2s are 8. Okay. Or otherwise do one thing. 2 1s, 2 4s. 2 1s, 2 4s. Okay. So the remaining values, 10 cube into 20 into 20, 400 into 30 whole divided by 64 into 1963.5 into 4 4s are 16. Okay. 16 ones are 16. How many times 400? 16 5s are 80. 16 5s are 80. I think 16 20 5s are 16 20 5s are 400. And 2 15s are 30. 2 32s are 64. Now N is equal to 25 into 15 into 10 cube whole divided by 32 into 1963.5. Okay. Now N is equal to, if you calculate you will get number of turns. Okay. So here I got numerator value as 375,000 by denominator value 62832. Okay. So if you calculate, we get around 5.968. So N is equal to 5.968. It's a decimal number, but N is always natural number. Okay, number of turns means we get 6 turns, 7 turns, 8 turns, like that. We always consider counting numbers. So here we got decimal number. So 5.968 is very much closer to 6, natural number 6. So number of turns required is considered as 6. So N is equal to 6. Therefore final answer is N is equal to 6. So axial load on the spring is 1963.5 newtons and number of turns required is 6.